am Abhinay and I have come up with a new video today. So today's video is a very interesting one. So please make sure that you watch it till the end. So let's begin our video. So the topic of today's video is time dilation. So the topic is time dilation, and this concept of time dilation was given by Albert Einstein. So to understand time dilation, we should first understand that what is time, that what exactly time means. So one may say that it is a very deceptively simple question, that what is time. We all know that time flows from past to present to future. So it's a very simple question, but actually time is not that easy. Understanding time is not that easy, because we can't actually weigh time, touch time, or see time, but we can experience time. So time actually has an independent existence according to Albert Einstein's theory. So how time exists? So time actually combines with the three dimensions of space. So we all know that space has three dimensions. This is the space, and there has three dimensions: the x-axis, the y-axis, and the z-axis. So let us consider any point P here. So the coordinates would be x1, y1, z1. But due to the combination of space with time, there is actually another coordinate of time here. So space actually combines time actually combines with the three coordinates of space to form a four-dimensional entity. And that entity is known as space-time fabric. So here I have shown that it is a space-time fabric. It is like this. So it is a space-time fabric. So it is a four-dimensional entity, and we know that the human mind cannot imagine four dimensions. We can only imagine three dimensions. But actually, when Einstein was making his theory of relativity required the existence of four dimension, and that four dimension was that of time. So it is the space-time fabric. So what happens that actually objects with mass cause a depression or a curvature in space-time fabric. So let us consider a mass capital M. So it has caused a depression or a curvature in the fabric of space-time. So what will happen that some another mass, that is M, small m. So capital M is greater than small m. So when this small m comes towards it, so due to that curvature or due to that depression, this small m starts revolving around the capital M mass. Okay. So just like what happens in the solar system. So what Newton actually said that the gravitational force of attraction between the sun and the planets is acting as a centripetal force, due to which all the planets are revolving around the sun. But Einstein said that no, it is not. It is not so. That is, the planets revolve because their mass is less than that of the sun, and due to the sun, which has higher mass and which is causing a greater curvature, the planets with lower mass are revolving around it. So it is a curvature in space-time fabric. So it means that gravity is not a force, but it is a curvature in the fabric of space-time. So according to Einstein's relativity, gravity is not a force, but it is a curvature in the fabric of space-time. So now let us come to our topic, the main topic, which is time dilation. So what is the meaning of time dilation? So the meaning of time dilation is the difference in the elapsed times measured between the two different clocks which are identical. That means that the difference in the measured times between two different clocks which are identical. So this is known as time dilation. So time dilation has two types. There are two types of time dilation. The one of the type is due to one of the type is relativistic time dilation, and the other part is gravitational time dilation. So let us first come to relativistic time dilation. So relativistic time dilation is given in the special theory of relativity by Einstein, which he formulated and published in 1905. So, special theory of relativity only deals with inertial frames of reference. It does not deal with non-inertial frames of reference. So, in relativistic time dilation, what happens that let's say there are two bodies. So the body A and the body B. So the body B, so it will find that the body B will find that the clock which is at A, which is moving with respect to means which is moving with respect to B, which is moving with respect to B. So the clock at A will be found to be ticking slower than the clock at B, which is at rest in their inertial frames of reference. That means the clock at B, which is at rest in the inertial frame of reference, in this inertial frame of reference, and the clock at A is moving. So the clock at A would be found to be ticking slower. That is, the time at clock A will be found to be moving slower than the time at clock which is at B. So so this is so this means that whenever there is a relative velocity between two objects, so there is the relativistic time dilation. So in this case the speeds are very low, but if the speed is very high, such as we approach the speed of light, so at the speed of light, whenever the relative velocity approaches the speed of light, the time actually gets stopped. The time actually stops. So this phenomenon works dramatically with higher speeds. For example, if there are two persons and one person is on Earth and the another person travels in a spaceship in the space at a very high speed, and then he just travels it for 1 minute and comes back to Earth. So when he comes back to Earth, so it might happen that for him, for that person in the spaceship, for him only 1 minute has passed. But for the person which is on the Earth, for him at the same time 10 years might have passed. So this is due to relativistic time dilation. This is because the time this does, and both the observers, both the people are equally correct. They don't it is not the mistake of the clocks, it is the nature of the space time. Due to this, it is said that time is not absolute. There is no specific tick tock that goes all around the universe. So that's why it is the relativistic time dilation. So now we come to gravitational time dilation. So the gravitational time dilation was discussed by Einstein in his general theory of relativity, which was given by him after 1905, many years after 1905. So in general theory of relativity generally deals with non-inertial frames of reference, or also known as accelerating frames of reference. So here is the concept of gravitational time dilation. Here is the concept of gravitational time dilation. So what do you mean by gravitational time dilation? It means that the body at lower potential, the body at lower altitudes or the lower gravitational potential will have the time going slower than the body which is at higher altitude or higher gravitational potential. So for example, if what we can say that if a person is climbing up, if a climbers if the that the climbers time is moving fast at the top of the climbers time is moving fast at the top of the hill, or top of the mountain, because the gravitational potential here is high as compared to the people at the sea level. So the time at the top of the mountain goes flows in high, flows fast as compared to the time at sea level. So that is the difference between the gravitational potentials. So we can say that like the GPS system. So one more most familiar example comes here is of the GPS system. So what we do that in GPS system, the GPS satellites actually they revolve around the Earth at 7,700 meter per second. So the GPS satellites are revolving around the Earth. It means that there is a difference in the gravitational potential between the GPS satellites and that of the Earth, and also the GPS satellites are revolving around the Earth. That means that there is a relative velocity between the Earth and the GPS satellites. So here both the effects come into existence: the relativistic time dilation also and the gravitational time dilation also. So due to this, what happens? At GPS, the time, uh, for example, the rate of flow of time in the GPS and that of the Earth is different. So let us say that there are two persons of 44-year age who whose whose whom whose age is 44 years of them. So one is an astronaut of 44 years age. He is at he is at International Space Station. Suppose we can say that because this is GPS system, so we can also consider it as International Space System also. So International Space Station also. We can here I have written GPS satellite, but it can also be analogy to International Space Station also. So International Space Station, which revolves around the Earth which revolves around the Earth. So a person at ISS, actually, if there is an astronaut at ISS and he is of 44 years age, and also a person is on Earth who is also 44 years of age. So after 6 months, the person at Earth will have his age as 44 years and 6 months, but the person at ISS would have his age as 44 years and 0.005 seconds less than 6 months. So the effect is not so much dramatic, as the difference in potential is not much, and also the relativistic speed is very less, that is 7,700 meter per second, because actually ISS and GPS both revolve around the Earth at 7,700 meter per second. They both revolve around the Earth at same speed. So if let us consider the case of GPS satellites. So GPS, if we do not consider the effect of time dilation, then GPS satellites, uh, then if we have to go somewhere through the GPS system, so what will happen, that if we have to go to a hotel, then it will send us into some another random place, if we not consider the effect of time dilation. But due to the effect of time dilation, because here there are both type of time dilations, the relativistic time dilation also and the gravitational time dilation also. So due to this, the clocks in the GPS system are calibrated in accordance with the time dilation. So friends, here with this I end my video on time dilation, and hope you like it and hope you have gained some knowledge. And also knowledge never gets waste. So hope you have gained some knowledge and some um, and have understood the things that I have actually taught very in a very simple manner. Actually the concept is very complicated, but I have tried to make it simple. So hope you understand it. And so with this I end up my video. So at the end, please like my video, and also subscribe my channel if you have not subscribed, and also share my video. And also please tell your friends, relatives, acquaintances, family members to like my video, and if they to at least view my video, and if they like it they should like it, and also tell them to subscribe my channel, and also to share the videos. So at last I would like to say thank you. Bye bye.